Hi everyone, this video is for lesson 12.4, which is when we start adding and subtracting our rationals. So I printed this at home from the PowerPoint. It printed giant. That's okay. I'm only going to do a couple problems in this video. They're more for review because this is a challenging lesson. So if you need to watch the examples again, this is for you. And if you were absent, this is really for you. So these are in your notes. These were when you have a common denominator, you just add your numerators over your common denominator. So this is what we get, and then you simplify. So when you have a common denominator, like for this one, the denominator for both of these fractions is x minus 2. So I have a common denominator, so I can add or subtract my numerators. So on the top, I would have 4x minus x all over that common denominator. And then I would say 4x minus x, well that's 3x over x minus 2. Those are not bad. Fortunately, we don't have a lot of those. So here are, I'm going to do two, I think, an add and a subtract with unlike denominators. And I think I'll do this one to start. Again, these are from your notes, they're example 3. So your first step, you want to factor, and then we'll find the least common denominator. So think about when we did the least common multiple problems, we literally factored even our numbers. So I might want to factor this and call it 3 squared. You know, you'd do a factor tree on 9. You would tree it. You'd have 3 times 3. We want to write repeated factors as exponents. So I'd have 3 squared x squared if I factored that. This binomial, I'm noticing right away, it has a common factor of a 3x. So I'm going to take out, oops, this would be over 7 here. So I'm going to factor a 3x out of both of those terms, so I would be left with x plus 1. And then you want to think, okay, what's a least common denominator here? So I need each factor, the 3, the x squared, the 3, the x, and the x plus 1, represented at least once. So I just start with the one on the left, start with the fraction on the left. Okay, this has a 3 to the second power. This one has a 3 to the first power, so I want to take the higher exponent, so I'm going to take 3 squared. This has an x to the second power. This has an x to the first power. I'm going to take the higher exponent. So x squared. Go to the next fraction. I already took care of the 3 and the x because I have those here. But I need that x plus 1 factor represented. So my least common denominator is going to be 9x squared, x plus 1. And if you look at this back here, let me write this as the 9 again. Another way to look at this is think, all right, 9x squared, 3x. Well, 3 squared is 9, so I need a 9. I need an x squared. I need an x plus 1. So that would be your least common denominator. So what you want to think is, all right, I want to make a fraction with a common denominator of 9x squared plus 1. I'm going to grab a different color here for this next part. So if I want, here I have 9x squared. I want 9x squared plus 1 as my denominator. So what do I need to do? What is this fraction missing on the bottom? It's missing x plus 1. So I want to multiply the denominator by x plus 1. But whatever I do to the bottom, I have to do to the top. So what I'm doing at this first fraction is multiplying top and bottom by x plus 1. So the new numerator over here would be 7 times x plus 1. Okay, now this one has 3x times the quantity x plus 1. I need it to be on the bottom, 9x squared times the quantity x plus 1. I already got an x plus 1. So I have to think, what do I need to multiply 3x by to get me 9x squared? Well, that would be 3x. 3 times 3 is 9. X times x is x squared. So now if I multiply all of this together, my new denominator, I'm going to have 9x squared times x plus 1. That's what I'm shooting for. That's what I want for my common denominator. But I have to multiply top and bottom by 3x. So now I have 9x squared, x plus 1 in the denominator, and in the numerator, don't forget this is a plus. We haven't actually done our addition yet. X times 3x would be 3x squared. Okay, now we can actually do our addition. Add our numerators because we have a common denominator. So that would be 7x plus 7. Don't forget to distribute that 7. Plus 3x squared over 9x squared times x plus 1. Now I always need to check and see if this can be simplified. So I want to see if this numerator can be factored. I need to write it in standard form first to see if it can be factored. Okay, so it's in factored form now. I don't see a greatest common factor, but I'm going to think, well, if I were going to do x box, I'd have a times c on the top, 21, b on the bottom. So factors that multiply to give me 21 and add to give me 7, there are none. So I cannot factor the numerator, so then that is done. Okay, I'm going to do a subtraction one next. I think this is, I don't know what example this is, but find this one in your notes. We always want to start by factoring anything and everything. This is a binomial, no greatest common factor, not perfect squares, numerator cannot be factored. This numerator cannot be factored. I'm pretty sure this can be factored, and I'm already noticing this has a greatest common factor. So I'm going to rewrite these. Numerator staying the same. This trinomial, there's no greatest common factor, so I can go right to my binomial. A is 1, so I know I need x times x. This is positive. That tells me both the signs in my factors will be the same, and this tells me they'll both be negative. There's only two factors of 2. They're 2 and 1. So x squared minus x minus 2x, that gets me minus 3x plus 2. Okay, so that looks good. Minus negative 2x minus 1. And this, I said, looks like we can take out a common factor of 2. So 2x minus 4. So that factors into that. So now for your least common denominator, okay, I have an x minus 2, so I know I need an x minus 2, and I know I need an x minus 1. Remember, I need to represent each of these factors the greatest number of times it appears. And then I go to my next fraction. Ooh, I need a 2. I'll stick that in right here. And then x minus 2. Well, I already have an x minus 2. I don't need to repeat it again. So this is my common denominator. So I want to rewrite both of these fractions so that this is the denominator. It's a little different than when you do it with numbers. Here you kind of figure out your common denominator. It's just a little easier to do it that way, and then go back and think, okay, this fraction has a denominator of x minus 2 times x minus 1. My common denominator has x minus 2 times x minus 1, but also a 2. So I need to multiply the top and bottom of this fraction by 2. So don't forget to wrap this numerator up. So when I multiply the denominator by 2, that's going to get me my common denominator that I want. And the numerator will get me 2 times 5x minus 1. Okay, now the second fraction is 2 times x minus 2. I need 2 times x minus 2. Got that. I'm missing the x minus 1. So I need to multiply top and bottom of this one by x minus 1. So be careful up here. This is multiplying two binomials. This is going to be minus 2x minus 1 times x minus 1. That's my new numerator over my common denominator. Okay, now I can actually do my subtraction. Remember, don't start wanting out right here. You haven't subtracted yet. It's a subtraction problem. You need to do your subtraction. So this I'm going to distribute. So my numerator here is going to be 10x minus 2 minus, I'm going to put all this in parentheses because I'm going to have to distribute that negative. This would be negative 2x times x. That would be negative 2x squared. Negative 2x times negative 1 would be positive 2x. Negative 1 times x would be minus x. And negative 1 times negative 1 would be positive 1. Okay, and then my common denominator. All over my common denominator. These I can combine, right? 2x minus x, that would just be x. And now I'm going to distribute this negative. Don't forget, in these subtraction problems, you're going to have to distribute this negative. So now my numerator is 10x minus 2. Negative times a negative is a positive, so I'm going to have plus 2x squared. Negative times a positive, negative x. Negative times a positive, minus 1. All over that common denominator. These are long, right neat. Do I have some like terms? Yep, I can combine the 10x and the negative x and the negative 2 and the 1. I'm going to try working to the right here. I'm also going to put it in standard form, so I'm going to put my 2x squared first. 10x minus x would be plus 9x. Negative 2 minus negative 1 would be minus 3. All over 2 times x minus 2, x minus 1. We need to see if that can be factored. It doesn't have a greatest common factor. So negative 6 and 9. So this is a negative. I know I'm going to have a negative and a positive. The only factors of 6 are 2 and 3. Those are not going to multiply or add to give me 9. And 6 and 1. Those are not going to add to give me 9. So this cannot be simplified any further. Okay, that's it. Just another shot at these adding and subtractings. They can be tricky.